So what is serverless? Serverless is a piece of code that runs for a reason. That means a timer might have gone off, or we have a new file in the storage, or someone hits, for example, a endpoint with a web request. So serverless means that we have managed code in the cloud, but it also means that we pay for what we use. So this is the main reason why people use serverless or consider using it. It's very, very cheap. Of course, it scales because it runs in the cloud. Just as an example, let's have a look at what cheap actually means. So here we have a function that can take up to 128 megabyte of memory. We also say that the function can run for a full second, which is a lot. Most functions run for a few milliseconds. Looking at the number of executions per month being 1 million. At the right here, we can see how much that will cost us, and we can see that it's for free. Looking at our next slide here, we see that we have scaled the number of executions per month to 5 times, 5 million executions. At that point, we're talking less than $4. That's a lot of prototyping, that's a lot of trying, or maybe low usage. It won't cost you an arm and a leg. Can we make everything serverless? That's actually a very fair question. Well, if we look at the code that we are currently have 100% uptime, that code is not a good candidate for serverless because it needs to be up all the time. Serverless actually powers down when it's not used. So let's have a look at the second category, the one called seldom used. Now, seldom used code is a better candidate for serverless. It doesn't need to be up all the time. So for that reason, making it serverless makes a lot of sense. Having a look at the serverless offerings on Azure, there are more than one, but in this case we are going to look at something called Azure Functions. Now, Azure Function consists of, first off, a Azure Function app. We usually say that this is our point of scale. Inside of our Azure Function app, we have X number of functions. Looking at the right here, we can see that we have a function and a trigger being the reason why the function is being called in the first place. We also have a concept called bindings. So an input binding is simply that we read from a data source before we trigger the function. That means that once the function runs, it comes with some data. Then we have the second concept, which is output binding. Now, output binding means that we have a reference inside of our function that allows us to easily write to a data source. We also have different authorization levels, which means how secure do we want this function to be when it comes to invoking it. Should it be anonymous, which means no API key, anyone can call it? Or should we maybe have a function level, which means using an API key? Or should we have additional security on the admin level? That's a choice that you need to make, but we are providing different levels. Let's have a quick look at the two major concepts here when it comes to Azure Functions. One of them being triggers. Triggers is the reason that the function is being invoked in the first place. And as you can see, we have quite a few options with blob storage, queues, webhooks, timers, and so on. Then we have bindings, which means, well, convenience code that's already being written for you. So instead of you having to write connection code for talking to a file, Excel, OneDrive, and so on, this code is there, and this is configuration that you are being given instead of having to write connection code. How can we write serverless? Good question. We can write or author serverless functions by either using the portal or VS Code, or we can actually scaffold what we need through a CLI in the terminal. We will now go and showcase a demo inside of VS Code. Before we do as much, let's have a quick look at how we can install what we need. Depending on what OS we are currently on, there are different instructions for how to install the core libraries needed for Azure Functions. On the Mac, we use Brew. On Windows, it's a simple one-liner to npm install. On Ubuntu, we need to add a reference to our package feed. And here on the right is a extension for VS Code that I highly recommend using because it helps us to scaffold code, debug code, and also deploy to the cloud. Okay, we are now inside of VS Code and we are about to scaffold a function app. And inside of that function app, we'll also add functions. We have installed the extension, and as you may remember, we have explained some concepts such as triggers and bindings. Let's bring up the command palette, like so, and select to create a new project. Now we select the current directory that we are in. Because this is the first time we create a project, it's also going to ask us for language for our project. You can see that we have quite a few languages to select from, such as JavaScript, TypeScript, C#, Python, Java, and even PowerShell. I will show you how to do this in future videos with different languages. For now, let's go with JavaScript. We select JavaScript. Because this is the first time we create a project, it will also give us the first function endpoint. We have covered what triggers means, but let's talk about them again. Triggers are the reason that our function is being invoked in the first place. You can see that we have a plethora of different templates to choose from. HTTP trigger, blob storage, event grid, and so on. For this video, we will select the HTTP trigger because we want to hit our endpoint through a browser or through, for example, Postman. Selecting the HTTP trigger means that we now progress in this wizard where we are asked to give the function a name. We should give it a good name, but for the sake of this video, we're just going to make it simple and call it get. Call it get, and the next step in the wizard is to ask us for the authorization level of our function. We have 3 different levels, as we said earlier. Anonymous, which means that anyone can call this function once we deploy it. Function means using an API key, and admin means added security. We will select anonymous. Now it's scaffolding the project for us, and it's already done. This is a pretty quick process. We get the package.json because this is a Node.js project. We get another interesting file here called local settings.json. This is a file in which we will store things such as keys for different data sources. But there are also some keys here that are specific for Azure functions. Should you in the future need to add keys for let's say a connection string for database, it would be added in here. You can also synchronize this file to your Azure deployment once we deploy. Let's also have a look at our directory get. This is our function directory, and we get 2 different files in here, one being function.json, which is a configuration file. This tells us things such as authorization level, which we selected to be anonymous. Also the type of trigger, which is HTTP. It also says what HTTP verbs that we currently support, which is get and post. We can change all of these values after the fact, so whatever we choose in the wizard, it doesn't have to remain that way. Let's have a look at this last element here. This is our return object. We say that it's of type HTTP and also that it goes outwards. This is being returned back to the user. We also select to call it res, but we could change this name if we want to. At this point, let's select index.js and let's have a look at what the code looks like. Well, first of all, it is a function being assigned to module exports with 2 different parameters, one called context and the other one called rec, which is short for request. Have a look at row 2 here, where we do context log. This is our ability to log how different things goes. Locally, you will see this being logged out in the terminal. Once deployed, there is an application log where we can see any kind of logs. This is very useful for debugging, for example. On line 4 here, we see that there are 2 different ways in which we try to get the name parameter. Either from the query, which means that we have used the get verb, for example, by using a browser, and this means that we have sent the name property through the URL itself, or maybe we have used post instead through a tool like Postman and posted the name property instead. Regardless of which, have we chosen one of these 2 options, that means we have a winning scenario and we will try to populate this context res property. Status 200 is implicit, so we don't need to set that if everything is good and okay, but we do need to set some kind of useful body message, which we do here by saying hello and the name value. Now, if we don't provide any of these, we come to line 10, in which we populate instead the res with an object of status 400, which is an error code. Here we set a useful error message where we say to pass the name either as a query string or in the request body. The next thing we're going to do is to debug our application and pop up a browser once it has finished compiling. To debug, we go to the menu and select Start Debugging. Now this will compile our project and it will end up saying that our endpoint exists at a certain port. Yeah, so now we can see that we have a link, and we also see that we have some kind of debugging process attached to it. So we can command click or control click depending on the OS we're on. We end up on localhost 7071 API get, and we can see that it is loading. Returning back into VS Code, we see that our breakpoint has been hit, and there's a lot of useful information on the request object, such as the URL, the method it was called with, and we can say the body is undefined because we're doing a get. You can also see that the context log object consists of a lot of useful information as well. So we are going to end up here because we don't provide the name parameter either through the URL or the body. So we're going to let this one pass through, and we see that we are constructing the erroneous object here with the status 400. Let this pass through, and we return to the browser, and we're going to have a look. And the browser is saying, yes, the error message, we need to pass the name of the query string or the request body. By simply saying like this, name equals Chris, we are passing it through the URL, we hit enter, and we are back, and this time around we can simply hover over rec query name, and we see that it's being populated. We expect it to hit here on line 5, which it does, and we can see that it's going to populate the body property with hello Chris. Press play, we're back in the browser, and we see this time around we get a different response and everything is well and good. In summary, serverless is about running managed code in the cloud, and we have a concept called triggers, which is the reason that the code is being invoked in the first place, such as hitting an endpoint or a new row in a database and so on. We have a real time saver with bindings, a concept that means that we have a lot of code written for us to connect with different data sources. And yes, serverless is really, really cheap. So don't place all your code in serverless, but code that is called some of the time.